Hi everyone and welcome to this video. As you probably know, order by RAND queries in MySQL can be very slow, and in this video we'll try to find a workaround for this problem. In the first part of the video we'll come up with two different solutions using only MySQL, and in the second part we'll implement this solution queries in a Laravel application. Please check out the description to this video for some useful information. And let's get started. For this demonstration, I will be using this table containing articles. It has this structure, it has a primary key, it also has an index which we'll be using in our conditions, and it has a couple of text columns, and the number of rows is around 50,000. Besides the articles table, I will also be using another table which contains much more data. The number of rows in it is around 50 million, so we'll see how our queries perform in either table. Okay, so let me start by running the original order by RAND query and see how it works in the articles table. Okay, run. So as you can see by this loading circle, this query is way too slow. It took 4 seconds to run, which is too much for such a simple query on such a small data set. So one way we can work it around is by creating a subquery that will select 5 random IDs for us, and then we'll join the rest of the table on it. This method is still using order by RAND, but you will see that the performance will improve significantly. Let's run it. And as you see, it only took 20-something milliseconds, which is a great improvement. Let's run it again. Okay. So what I want to do next is I want to run a similar query against the table that contains 50 million rows. So here's the similar query. I only had to change the name of the ID column here. So now let me run it. And as you can see, it's way too slow. It's way over 40 seconds. Which means that for a data set like this, we need a different solution. So let's go back to the previous query. And the problem is still in the order by RAND part. Maybe there's a way we can find random IDs without having to select them from the actual table. So let's try to find a random number based on the number of records in the table. So here's one random number, but it's float. I think we should better make it integer. Okay, now it looks like a possible ID from our table. But before we proceed, let me just examine this query. As you see, it's using the index, and to be honest, I have no idea why it should be using the index. So let me just work around it. Let me try using another subquery here. Okay, now we've got two queries, but neither of them is using the index or the table. So it should be much faster. Let's try it. Yeah, you see it's only 2 milliseconds. Okay, so it's giving us random numbers. So let it be our random number generator query, and now let's join it with the table. I'm also selecting my random ID because in some cases I will want to have a look at it. Okay, and limit 1. So now let's run it. Oops, I think I forgot to put an alias here. Okay. Okay, this query is very fast. It only took 2 milliseconds. But the problem of this query is that it will only work if we don't have gaps in our primary key, in our ID column. But what if I say that we do have gaps in this table? So let me show it to you. So as you see that in the range between 10,000 and 15,000, we only have one article, which means that there is a gap. So if we keep executing the query, at some point we will hit the gap. So let's do it. Okay. Now let me change my join real quick and hit the gap again, only this time with the right join. Okay. Okay, so the random ID is 11,000, and yeah, so the gap is between 10,000 and 15,000. So is there a way to work around it? The answer is yes, there is, and the workaround is very simple. You just have to change the condition here. By doing this, we're making sure that every time we hit a gap, we will go up that gap until we find the first record. As you see, the query is just as fast, but the problem is that it's not completely random now, because the IDs at the edge of a gap, especially if the gap is big, will be selected more often than the others. But this is something we will have to accept in favor of fast performance. Okay, how do we select 5 records now? Very easy, we just have to repeat the same query 5 times. And we'll use union for that. Okay, let me just copy and paste it 3 more times. Let's run it. As you see, the query is very fast. It is much faster than the other one. Okay, so what if I want to use a condition in my query? Well, then I probably will have to use that condition in every part of that big union query. So let me remove these unions here. Then let me write my condition where written at is greater than 2000. So basically I want to select all the articles of the 21st century. And I want to introduce another column here because my condition will create more gaps for me. So I want to see whether I hit the gap or whether I hit the existing ID. Okay. So you see ID hit, column shows that the real ID was hit. So now let me bring my unions back. Just copy paste it. 2, 3, 4, 5. Okay, let's run it. So as you see, I got 0 hits on the real records. So it means that every random ID that I have in this query has actually hit a gap. Because as I said, my condition created a lot of gaps in the ID. Okay, now keeping in mind that this query took 3 milliseconds, I want to try the previous query with the condition. So let's make the same condition. It's greater than or equals. Let's run it. And you see this query is slower. It took 10 milliseconds, although the randomness of this query is 100%. Okay. Okay, so one last thing I want to do here is I want to run the big union query against the table containing 50 million rows. So as you remember, the small query took a lot of time here. So let me just try and run the big union query here. Okay, so I changed the ID columns here. So let's run it. Well, as you see, it only took 20 milliseconds. So for the table with 50 million rows, it's very, very quick. Now let me run the order by RAND query. So as you see, the loading image is spinning round. Okay, it's about 20-25 seconds, which is too long compared with 17 milliseconds here. Okay, so now let's implement the queries we created in the Laravel application. So in order to get the app, go to my GitHub page and download the app from there. You can get all the guidelines in the description to this video. So after you've installed the app, you can go to this URL/articles and you will see the list of articles here. As you can see in the code, it's just the first 5 articles from the database. And by the way, in this app I'm using this debug bar, which is very helpful. It shows all the queries and all the necessary data for the web page. Okay, so let's try and use the order by random the old way. So let's reload the page, and you already see that it's taking too long, and it took 6 seconds, as you can see here in the debug bar. Okay, now let's change it around. Let's implement the first query from the MySQL part. It's the query that is still using the order by RAND, only in a slightly different way. So we will simply join our table with the select statement. Okay, let's remove the limit from here. Let's add the alias and the condition for the join. Okay, that's it. Let's run it. As you can see, the page is loading much faster. Okay, so for the second query, let me create a separate URL and a separate action in the controller. Let me just copy and paste it here. Now let me go to the routes and create a separate route for my action. Okay, let me test the route. Okay. So now instead of this subquery, let's use the subquery from the big union query. Okay, let's delete it here. Okay, let me copy this query now, the subquery. Okay, let me paste it. Change the condition here and add the alias. And here I want to limit it to 1. And yeah, you can see 1 more or less random record, and it's very quick. Okay, now let's add the union. So we need to change this code a bit here, because we will just be cloning these query objects and add them to the main query as unions. So I'm cloning the query object here, and I'm adding it here to the main query. And by the way, perhaps I shouldn't be cloning the main query every time in the loop. So I will create a special object for cloning. I'll call it query to clone. Okay, now let's go and test it in the browser. Refresh. Yeah, looks good. It's very fast and it's pretty random. Okay, now let me add a condition to the query. Let's say I want to eliminate all the articles written in the 21st century. Basically, adding a condition here will be as simple as adding a where statement to our query object, so there should be no problems with it. That's it. Let's go and test it, refresh, and we can see our condition in the query browser. And if we refresh the page, you see the condition is working. Okay, now let's go back to the first query and add our condition there. Well, of course, I could implement the condition by typing it directly in the subquery, but that's not how I want to do it. Instead, I want to create a subquery object so that we could use where statements and so on and so forth. So, as I said, with the subquery object, we can use as many where statements as we want to. And here, instead of join, I will use join sub, and this method will take the subquery object, the alias, and the callback function. Yeah, this should do it. Let's go and test it. Refresh. Okay, the condition is here in the debug bar. Let's refresh it a couple of times. Yeah, it's working, which means that this should be it for today's tutorial. Okay everyone, thanks for watching. Please like this video and subscribe to my channel, and see you in the next video.